If you're a fellow Marvel fan or a fellow Star Trek fan, you're gonna love this video. You notice how cool Iron Man's computer setup is? Just imagine your computer screen floating in space. I know. Or, you know what would even be better? If we had some kind of technology that this super cool holographic ring effect shows. Mind-blowing. In this video, I'm going to explain to you how holographic technology actually works and what you should expect for the future. Now the question here is, what is a hologram? A hologram is simply a photographic emulsion in which information about a scene is recorded in a very special way. When the hologram is properly illuminated, you, the viewer, see a realistic three-dimensional representation of the scene, like this. There are several techniques that can be used to create holographic images or displays. Today we'll be learning about computer-generated holography that uses computer algorithms to create holographic images without the need for the physical object. So far, the Gershwin-Saxton algorithm is the easiest way to implement CGH. The GS algorithm is like a game of guess and check used in making holograms. Imagine you're drawing a picture but can't see it clearly. You start by making a rough guess of what it might look like. In our case, we start with a guess about the light's phase while knowing its strength. Then, we use a special tool to see how this guess light will travel and behave. We compare what we see with what we actually want to see, recorded by camera. And they usually don't match up at first. So what we do is we tweak our guess to match the actual data used in the camera, changing the strength of the light. We keep doing this like a loop, adjusting our guess and checking against the camera's recording until they finally match. This process helps create a more accurate hologram that matches what we want to see. Imagine you have a special light that's super organized, like a perfectly synchronized stance. This light shines onto something called a spatial light modulator. This SLM is like a grid made up of tiny parts that can change the way the light behaves. Each tiny part can be controlled by a computer to tweak the light's movement. When this light passes through or bounces off the SLM, it goes through changes based on what the computer tells each tiny part to do. These changes in the light's path make patterns and affect how bright or dim it gets. Now, the goal is to figure out how to make the light create a specific picture or pattern somewhere else. To do this, we use the GS algorithm. It helps us figure out exactly what changes we need to make in the SLM so that the light makes the exact pattern we want. This method isn't the fastest, but it's pretty good at creating cool holographic images. Currently, there are a few limitations. A tad bit that hinder the mass use of this kind of technology, like how it has the potential for vast data storage capacities or how expensive its production will be. I know, we're getting there. But what can I say? I'm just a futuristic type of girl.